The third. And it's just lookalikes continued. So I don't know how you want to put that in your notes. Lookalikes continued. Dot, dot, dot. So we made it up to this point. This will be example number 7, x to the 8th plus 8x to the 4th menos 9. All right, let's get started. What do we do first? Yeah, I mean, I agree with all of that. Yes, what else? Yep, perfect. You guys nailed it. We're going to build a couple of shells. Excelente. I appreciate all of your input. And then remember, we know it's a lookalike because the exponents go 8, 4, 0. And I do need to clarify something as per a concern that came up yesterday. Understand that this is not, the question came up, and I was more clear with this during fifth hour. The question I got was, isn't this an exponent of 1? And if you were thinking that, let me clarify. When I talked about the exponents, I'm talking about the exponents on the variables themselves. The fact that the 9 has an exponent of 1 is completely irrelevant. What there is next to the 9 that you can't see is there is an x there, but it's to the power of 0. Do you guys remember your powers, your properties of exponents? What's anything when you raise it to the power of 0? It equals 1. Good job. And so really you could always make a case that there's a variable all over the place with an exponent of 0 because as you know, ones don't matter, right? So to be clear, when I talked yesterday about that pattern and lookalikes, it does go 8, 4, 0 because the 0 is on the x that you can't see, not the 9. Are we clear? Okay. Does that clarify that for you? Okay. So anyways, I'm not going to put that probably ever again, but it is a lookalike. It follows the pattern. And so we're going to put x to the 8th, half of that, so to speak. Not really, but half of the exponent, we're going to divvy up this way. And what are the signs going to be? One of each for sure. And what are the numbers that we're thinking? 9 and 1 for sure. Like 3 and 3 just would not foot the bill here. So we're going to put the 9 in the positive spot. So it is more heavy, more influential. And then we'll put the 1 over here in the weak spot. So any questions about that? Is it done? No. And then again, this will be our Mount Everest, so to speak, for this unit will be how do I know when I'm done? And you recognize that one of these, sometimes they'll both be factorable, by the way, but in this case, why is this red one dead? What's it? Because it's a plus. And remember, squares don't work with pluses. And so this would be what we would call a sum of squares, which is not factorable using real numbers. So the red is dead. So if you wanted to, just as a matter of like forming good habits, you could bring it down right now because it's just going to stick around now. What about x to the 4th minus 1? What is this? He has a name. It's a difference of two squares, and they get really offended if you don't call them by their name. So make sure you start looking for those. If it's something squared minus something squared, you must identify those. Okay, that is a difference of squares. Now, mind you, it's a buffed one. It's a look-alike difference of squares, so it's got the higher power, but it is still what it is. And to do a difference of squares, you merely take the square root of the purple thing and the square root of the yellow thing. That's it. That's all it is to factor a difference of squares, and you build two shells out of those. So we're going to go little shell, and we're going to go square root here, here, square root here, here, stick a plus in one, stick a minus in the other. Oof, now are we done? No, I see some people shaking their heads. And as I alluded to yesterday, sometimes even 2 steps isn't enough. The offspring can create their own offspring, who then subsequently create their own offspring. Like in this case, I identify now that I do have 2 dead factors. X to the 4th plus 9 was dead, still is dead. Who's the new dead guy? The plus 1. Sums of squares cannot be factored. So x squared plus 1 can join the ranks of dead weight. But what is x squared minus 1? What's it called? Remember, he likes to be called by his name. It's a difference of two squares. They like that stuff. And so when I factor that difference of squares down, again, I just think fundamentally about square roots. If I can do square roots, I can factor a difference of squares. What will the factors of x squared minus 1 be? X are the square roots, 1 are the square roots, and what are the signs? Plus and minus. And at this point, it has to be dead. You can't factor a linear factor down anymore. Linear meaning these are x to the 1 power and x to the 1. That's when you know you've just like gotten to the bottom, so to speak. This has to then be the final answer because we filtered all the dead factors to the left as we worked, and all the ones on the right are also dead now. So there's an example of a 1, 2, 3-step factoring problem. And that's usually about the furthest I'm going to ask you to go. It's about 3 steps. I can make them more obnoxious. Like if I give you like x to the 8th minus 256, which we don't have to do, that would take, I think, 4 steps, just for the record, but you get the idea. All right, let's go again. Example number 7. X to the 4th minus 13, x to the 2th plus 36. What's this? What's he called? Bless you. Thank you for saying that. It's a lookalike, right? And we know that lookalikes, we treat them just like quadratics. So we're going to build 2 shells. What's going to go in the fronts of the shells? X to the 2nd. Remember, that's just taking half of the first power. Again, just to be clear, we know it's a lookalike because of the power pattern 4, 2, 0, right? So, I mean, we're not just making this up. What are the signs going to be? Minus, minus, and what are the numbers? You could try 6 and 6. And this is part of the factoring process, as I've tried to stress to you from day one. Part of factoring is trying things and they don't work. And this works for the x to the 4th, and it does work for the plus 36. But if you check your purples, you get mine. Yes, you guys are on to it. Minus 6 and minus 6 won't make minus 13. So we can just rule 6 and 6 out. It's no big deal. 9 and 4 will work. If you put a 9 here and a 4 here, we still have the 36 covered, of course. But now, more importantly, we also make the minus 13. Is this one done? Which one's factorable? Both of them are. This one is called a difference of 2 squares. This one is called a difference of 2 squares. And you can take this or leave this, but from what my experience tells me, almost all the points get lost when people can't see differences of squares. I don't know what it is about them, but you have to look for the 3-step test. Test 1, is x squared a square rootable thing? Yes. Test 2, is 9 a square rootable thing? Yes. Test 3, is that a minus sign? Yes. Can't stress enough that if you just pass those 3 tests, you're factorable. What are the factors of the first guy going to be? What will I put in my parentheses? X and X, of course. What else? 3 and 3. What are the signs going to be? Plus and minus. Yeah, easy peasy. What about the second guy, x squared minus 4? What are his factors? When I ask you what are the factors, I'm not asking for 2 and 2. I should be more clear with my expectations. I'm asking you to fill in the red parentheses and fill in the green. All the stuff collectively in parentheses is called a factor. So when I put something in parentheses like this, x plus 2 is now what we call a factor. Got it? X isn't a factor, 2 is not a factor. X plus 2 is a factor. It's a multiplicative part of a bigger picture. And what's the other factor? And that has to be a finished product because they're all linear factors. So linear factors can't be busted again. So any questions on that? Okay. Next one. Ooh, we're on to the right side of the note card now. This is good. X to the 6th minus 12x cubed plus 32. He's a lookalike, huh? Pattern 6-3, nothing. 6-3, nothing. Fits the mold. What do we do first? Build your shells, idiot. Half here, half here. What are the signs? Minus, minus. You can see how frustrating this class must be for someone right now if you're not 100% good on the basics from last week and the week before, right? The signs and all that has to just be 100%. Never mess up. All right. And what are the numbers we're looking for? 8 and 4 are perfect. Which one of these is factorable? They're not both factorable. And I wrote problems. I write these completely. Like I do not just pull these off the internet. I want to control what I'm asking you. I wanted you to think that this was factorable so that I can have this talk with you. What is he really wanting you to think he is? Maybe someone might say it's a difference of cubes. Someone else might say it looks like a difference of squares. And while both of those people, their hearts are in the right place, they're both sadly mistaken, right? Where does it fail in being a difference of cubes? The thing I have underlined in red, where does it fail in being a difference of cubes? The 4 is not a cube. Therefore, you have to get that thought out of your mind. It is not a difference of cubes. The x cubed and the minus sign I planted there to get you to be maybe a little bit enticed. That's part of this learning process, is to stop falling for my traps. And where does it fail in being a difference of squares? The cube, x cubed. So it fails each one in a different way. The x cubed makes it not a difference of squares. The 4 makes it not a difference of cubes. Therefore, it is dead. So I would take the x cubed minus 4. I would filter it out to the left and say, you're done. Now I have to tackle the green one. Is it factorable? We're going to practice this a lot. The answer is yes. It never had a chance to be a difference of squares, quite frankly. The x cubed ruined it right away. The 8 ruins it right away. Neither of those are, God, I mean, they're not even squares, but it is cubes. And remember, with cubes, it doesn't even have to be a minus. A plus or a minus will do just fine. Is that a cube? The thing with the purple arrow pointing at it? Yeah. Is 8 a cube? Yeah. At this point, whether it's plus or minus, you get the green light you had on. And just like on today's quiz, I need to see you writing A and B. And so what in this case is A? Yes. And what is B? Yes. That will be worth points on today's quiz. I want to be clear, and I'll tell you that again when I hand out the quizzes here in 5 or 7 minutes, whatever, but that is worth points. Even if you get the problem right, I'm telling you, I need to see your A and B. Okay? So here we go. Right. Yeah. Like if I'm writing a test question and if I put x cubed minus or x cubed plus, I have a decision to make right now. Do I want my students to factor or do I want them to stop? And if I put like a 9 here, I want you to stop because 9's not a cube, right? But if I put like a 64 here, I want you to go on because 64 is a cube, right? So just keep thinking about that. Short set. What is short set? Correct. What's long set? Couldn't have said it better myself. And if you're really paying attention and listen to everything I say, and by chance remember everything I say, you will remember I told you this, money back guarantee, long set is always going to be dead. Okay. So we can rest assured that since x cubed minus 4 was dead, x minus 2 is linear, it's dead. Long set, my teacher told me, is always dead. Therefore, this has to be the final answer. Okay. Okay, we have 3 more examples. They're a little bit more difficult just because there are now numbers in front. So, but the idea of how to treat a lookalike is not going to change. It's definitely a lookalike, huh? It's got the pattern 420. So we know now that we can build our shells. Why is this problem a step up in difficulty? The 9. The 9 is going to mess us up here. So we know that we've got 2 potential templates. One template would be 3x and 3x. And one template would be 9x and 1x, right? We're still just factoring quadratics here. That's why we do that first, because everything hinges on your ability to do that. Right. And I'll put the other template, even though I'm pretty sure it's not going to be this one, but I'll put it down just so I can say I did my due diligence. What are the signs going to be? One plus and one minus because they multiply to make a negative. The good news about this problem is that there's only one way to make one, right? So if this doesn't work, then this has to work, right? And by has to work, I mean we might have to switch the signs, but yeah, who cares? Does the top one work?
Yeah. Yeah.
The answer is no. And you shouldn't fall for garbage like that. Okay, I'm here toying with your emotions. What do those make? What do those make? The fact that you said yes tells me you need to answer this question. What do those make? 1x. The purple thing is 1x, right? What do those make? Negative 9x. And what is 1 minus 9? Negative 8. So don't be hasty, right? We're not looking for negative 8. We're looking for positive 8. So the answer is no, it does not work. I have to switch my plus and minus to a minus and a plus. And I forgot to put my exponents on there. I apologize for that. Got it? Done? No. Why not? What is it? Yeah, say it. Yeah, just practice saying it. And the more you say it, the less you'll have to think about it in the future. It is a difference of two squares. Is the second one factorable? This one? What do I, when I wrote this on Monday night or whenever I did this, what did I want you to think it was? What a difference of squares, right? And a lot of kids think, oh, it's squares. X squared is x squared and one. Plus ruins it. Squares don't work with pluses. He's dead. So I'm going to filter him out to the front. X squared plus one is a no-go. Red light on that. To factor a difference of squares, you simply have to know how to do square roots. What's the square root of the purple thing? 3x. What's the square root of the green thing? So you just simply build. And I'm simply, I don't mean to like talk down and be rude, but like it is simple. Once you can take the squares, you just build it. You put them in their places and build it. What's the first factor going to be?
Yes.
Thank you for answering that like that. Thank you. That's a factor. What's the other factor going to be? 3x minus 1. And it is done. Sure. Yep.
How did we get 2x?
Because the middle term of the long set when you factor cubes is always AB,
Okay.
and x times 2 is 2x.
Okay.
Got it?
Yep.
All right. We ready for this would be the penultimate example, right? Number 11 out of 12. 12x to the fourth minus 19x squared minus 18. If you were doing this on your own, you'd be faced with the dilemma. You'd be faced with the unfortunate situation where it could be 12x squared and 1x squared, or it could be 6x squared and 2x squared, or it could be 4x squared and 3x squared, right? In the interest of time, that I don't want to subject you to any sort of torture, I'll just tell you that we're looking at 4 and 3. Okay, so having been the guy that wrote the problem, I'll just save us all a little bit of time and tell you that this is the template that we want to use. What are the signs going to be? Yeah, for sure. 1 plus 1 minus. And again, always use a pencil when you're factoring because you never know when you're going to have to erase them and switch them. No one likes that scribbled out pen stuff. Right? Numbers? Sure, let's try a 9 and a 2. Does it work? Thank you. So we didn't fall for it this time and say yes. We understand that the math is pretty good. It doesn't quite work, but it's still really, it's a lot of progress. This is 27 on the positive side. This is negative 8. And 27 minus 8 is 19. But we didn't want 19. We wanted negative 19. Parker was right on it. Instead of plus and minus, we want minus, and plus. Right? It's really no different structurally, functionally than factoring a quadratic. It's just got more meat on the bone. This one done? No. You can see there's a pretty common theme for today's lesson, right? Don't assume you're done. We can all agree that this one, the one I just circled in red, is just trash. Absolute trash. The 3 ruins it for being a square. The plus ruins it for being squares. The 2, I mean, it's just pure definition of trash. So we're going to filter 3x squared plus 2 out to the left. Is the green one factorable? What is it? What's his name? He says, thank you for calling me by my name. I'm a difference of squares. You can call him Fred or something, but it's the difference of squares. He wants to be identified like that. So it's going to be square root plus square root times square root minus square root. And again, if we've already demonstrated that one of them's dead and those are living, they all have to be dead. And that completes that. That would have taken a little longer, but again, I just wanted to throw you a bone and get through this. So last one, I'll kind of give you the same help. Can I scroll? May I scroll? Everybody good? So yeah, if you're doing this, what we're about to do on your own, the beginning might take you a little bit longer. But having the desire to move on and get on with our day, I'm going to throw you a bone here. So it's a lookalike, right? 630. So we're good to go. We're good to proceed. There are multiple templates, right? 8 and 1 or 4 and 2. I'll just cut right to it and tell you that we are looking in the 8 scenario. So we're going to put half of our x to the 6th here and half of our x to the 6th here. 8 and 1 are our guys. What are the signs going to be? Plus and minus. And I can't help but think that you agree that putting the plus here is smart. Why? I need weight on the positive end, right? And if I put a plus there, whatever number I put where that purple arrow is pointing, this product that doesn't exist yet is going to be strong. And I want it to be strong because I got to climb all the way up to positive 63, right? So again, factoring is not a guessing game. It starts out like one, but it becomes not one. So the plus has to go there. The minus is definitely going to go here. And the numbers, do you know what they are? Yeah, we want to give a lot of strength over here. If you put an 8 way over there, that 8 powers up with the other 8. Boom, and you get 64. And you're real close to 63. And conveniently, 64 minus 1 is 63, right? So step 1 is done. Is it dead?
The second one is the first is not.
You think that this one is dead?
No.
I don't know. I'm just asking. Do you think that? Would you bet that?
8 is cubable.
8 is cube rootable. It's a sum of cubes. So this, for our final example, I wanted to make sure you got to see one of these. Both of the offspring factors that we just created are each in their own right cubes. I wanted to make sure you got to see this last so you understand how these things can bite at you, take swings at you, throw haymakers at you. The one that I'm going to underline in green is a difference of cubes. The one that I'm underlining in yellow is a sum of cubes. So the quiz you're about to take, you have to just do 2 of those in the same problem. No big deal. For the first one, the green one, what is A? What's the cube root of 8x cubed? 2x. Good job. What's the cube root of 1, or what's B? B is 1. Let's switch colors and go to yellow. For the second one, what is A? And what is B? We have all the component pieces that we need now, and we're going to build this correctly. We're going to go short set, long set, short set, long set. For the first time ever, we are going to build 2 short long sets in the same problem. Both offspring were cubes. Neat. So what is my first short set going to be? Green only.
2x.
Nice. What's my long set going to be?
2x.
Da, da, da. 4x squared.
Plus 2.
Plus. Good. Let's move on to yellow. What is my shorty going to be in yellow? X plus 2. Way to get those signs. And what's my long set with yellow? Eesh. Minus 2x plus 4. And I will highlight for you something important. I'm about out of colors here, but I'm going to use red. Notice that in this one, minus was the original sign, therefore minus got used early. In the second one, plus was the original sign, so plus got used early and the minus got kicked to there, right? So it's a good warm up for today's quiz anyway. So that concludes the lesson on this. A little longer than I meant, but that stuff takes time. I'm going to pause this because I think your quizzes won't take long and then you might have some questions on homework. So I'm going to keep the recording paused, keep it alive.